Okay, in my last video where we were factoring basic quadratic trinomials where the a value is equal to 1, I started to do this one and I'm like, no, I'm going to do it in this video. And the reason I wanted to do it in this video is because this looks a little different than the other ones. And the reason is because we don't have a middle term, do we? All right, there's only two terms in this, so it's not really a trinomial, it's a binomial. But if I insert a middle term, so spread it out so that I do have a middle term, what would that middle term have to be? What would my b value have to be? Since there's nothing there, it's like I have a 0 times x. Okay, so I could use my factor patterns or my strategy from last video in order to factor this. So I could say, okay, what two factors multiply to give me negative 16? So that could be 1 and 16, 2 and 8. 3 does not go into it, 4 and 4, and I'm done. And again, one has to be positive, one has to be negative, so I'm subtracting. So which one of these subtracts to give me 0? Has to be this one, right? So one of them is going to be positive, one of them is going to be negative. Since they're both the same number, it doesn't matter which way I do it, right? I could put the positive one first and the negative one second. Okay, so I want you to think about this one. We'll do it together. So if I rewrite this one, x squared, and then now I'm going to put a plus 0x minus 49. Okay, 49 is kind of nice because I've got 1 times 49, and then I've got 7 times 7, right? I don't have anything else that goes into 49. All right, so I'm thinking 7 and 7. So I don't know if you've noticed this already, but when I have a middle term that's 0, and this term is, do you notice how both these constant terms were negative? So we always had one negative, one positive. But if I'm going to have a 1 negative, 1 positive, and my middle term is going to be 0, then don't these factors, these two numbers, have to be the same? If I'm going to subtract two numbers in order to get 0, don't they have to be the same number? Okay, so noticing this pattern, this is a factor pattern called, and it's, think of it like a shortcut. It's called the difference of two squares. Difference of two, we call it this because difference of two squares describes what we are given. So if I'm given something with a minus sign between two terms, that's the difference, right? It's the subtraction. And then I'm talking about two squares because these numbers, these terms, are going to be perfect squares. And what do I mean by perfect squares? Remember, perfect square is like 1 or 4, because that's 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9, and so on. And we can make our list. So that's what this is talking about. That's why it says a squared and b squared, because they're perfect squares. All right, so I don't know if this is making sense to you as far as variables, but x squared is a perfect square because if I made my list, right, this is just x squared, but what was this original thing? This original thing was x, and I squared it to become x squared. So the square root of x squared is simply plain old x, okay? So 49, the square root of 49 is simply 7. So you see how those are ending up in our answer? Okay, ooh, went too far. So in this factor pattern, all we're going to do is, in order to get from a squared to a, to figure that out in our answer, I'm just taking the square root of that. So the square root of a squared is simply a. The square root of b squared is simply b. All right, so anytime you have a variable, you're just square rooting that variable, okay? Anytime you have a number, you're hoping it's in this list of perfect squares. If it's not, then this factor pattern does not really apply. Okay, so let's try to use the pattern on these. Okay, so instead of thinking about 0x, I'm just going to say, okay, what's the square root of x? Well, that's just, what's the square root of x squared? That's just x, right? So I'm going to put x and x in those two spots. What's the square root of 64? Oh, that's going to be 8. So that's going to be 8 and 8. Notice that I did the square root of positive 64 and not of negative 64. The reason is because, remember, this minus is what gives us the one number's positive, one number's negative. So when we're talking about how do I get to this b, I'm not considering that negative sign for at least the shortcut part. All right? So that I would be done with that. That's x plus 8, x minus 8. Do this one real quick. I'm not even going to pause the video. I think you can hopefully do this really quick as long as you know what the square root of 144 is. All right, so you should have x and x there. The square root of x squared is x. And then the square root of 144, hopefully you know, is 12. And then one should be positive, one should be negative. Boom, you're done. Okay. As far as solving, right, if I was solving this as an equation, I would set each of these equal to 0. And then I would solve. So I would get x equals negative 8 and x equals positive 8. One strategy I forgot to list in my intro video is if you had x squared minus 64 equal to 0, you did learn this in Algebra 2. You called this taking the square root method. So what you did in Algebra 1 is you added the 64 to the other side, and then you took the square root. And remember, your teacher taught you that you had to do plus or minus 8, right? And that's because you will get two separate answers like we did when we factored. Okay, so this is, we got negative 8, positive 8 when we factored, and we got positive and negative 8 when you did the square root method. So that was another strategy for solving quadratic equations. Okay. So why would we want to use this factor pattern? Well, it is pretty quick but these easy ones you could probably even think about. But what if you had ones like this? Do you see how we would not be able to do that, that whole, 0x in the middle term and all that stuff? And I'm going to show you other ways later, but even if we did the other strategies, this would be very difficult because this is a very large number in front of x squared. We no longer have just 1 in front of the x squared. However, if you recognize, oh, the square root of 121 is 11, right? And then the square root of 81 is 9. Those are whole numbers. So I can do my difference of two squares pattern. This is subtraction. So now instead of just having x and x, I would have 11x, because 11x times 11x would give me 121x squared. All right, and then over here, the square root of 81 is 9, so this would be 9 and 9. All right, one would be positive, one would be negative. Okay, so try this next one on your own. I'm going to pause it. Okay, so you should have gotten 2x plus 7, 2x minus 7. And again, the order of the parentheses does not matter. I do want to make sure you understand that if you are getting confused by this pattern, sometimes people get confused and they put the 2x and the 7 in the wrong spots. Always double check yourself, right? You can always see, if I were to FOIL this out or distribute that out, that would give me 4x squared minus 14x. This would give me plus 14x, and then 7 times negative 7 would give me negative 49. Okay, when I combine like terms, those would cancel out to give me 0x. So I would have 4x squared minus 49. I ended up with what I started with. So this is just a double check. So please, if any kind of shortcut is confusing you, always go back to the basics and the concept that made that shortcut.